Hello everyone. I hope you are doing fine. Welcome to this GEMS series of question bank where you are going to see a lot of questions explained to you in a best possible manner. We will be covering class 12th physics NCERT portions. So those who are coming here for the first time, please do subscribe the channel, and this will be beneficial for also those kind of students who want to just revise the portions before the exam. Okay, so let us start with this question. 4-point charges QA is equal to 2 microcoulomb, QB minus 5 microcoulomb, QC 2 microcoulomb, and QD minus 5 microcoulomb are located at the corners of a square ABCD of side 10 centimeter. What is the force on a charge of 1 microcoulomb placed at the center of the square? Okay, so let us draw the diagram to understand it better. So I'm going to start. Please ignore little tilted line. So QA is your, this is your A, this is your B, this is square C, D. Okay, D. So this is your 10 centimeter line. The side is 10 centimeter. Okay, the charges are already given. Let us just write it here. This is your 2 microcoulomb. B charge is minus 5 microcoulomb. C is 2 microcoulomb. And D is minus 5 microcoulomb. Okay, let us join this. Join this also. And at the center of this square, the point O, where your charge is 1 microcoulomb, where your charge is 1. So here your charge is, this is MO, this is your 1 microcoulomb. Okay, this is your 1 microcoulomb. So I have noted everything here. Okay, so now always remember, if I have to find force on a particular point due to many charges, so it depends like what is the system you are having. Suppose you are having a system of multiple charges. Here how many charges are there in the system? 5 charges are there, and we are trying to find force on what? On a one particular charge that is situated at the center. So when you are trying to find a force on a one particular charge in a system where there are multiple charges, then you use superposition principle. So the superposition principle states that FO vector, that is the force on the O point, will be actually equal to force on O due to A, force on O due to B, force on O due to C, and finally force on O due to D. This is your first step. So you have written the principle. Okay, this is like resultant of all these forces. If you get, you will get your answer. Now what is the second point? Second point, we need to get the directions of FOA, FOB, FOC and FOD. So I am going to do that. Let's see. So let us draw FOD first. Let us draw FOD first. FOA. So when you talk about FOA here, so O and A both are having positive charges. That means like charges. That actually means they will be having electrostatic repulsion. So the force on A due to A, force on O due to A, when I will be drawing, so I will be drawing it away from A. This is my FOA, my red line. So I'm just going to put a point so that it will be clear. The red line is indicating here FOA direction. Okay, let us go for the next. That is FOB. So when you talk about FOB, O is having positive charge, B is having negative charge. That means there will be attraction between those two charges. So when they have attraction, that actually means if I want to draw the direction of force on O due to B, I'll be drawing it towards B. That is attraction. So this is nothing but FOB direction. I'm just putting a dot so you exactly know that the green line here indicates the direction of FOB. Let us come to FOC. So can you help me with it? So when you see O is having 1, C is having 2, both are like charges. Like charges means electrostatic repulsion will happen. So repulsion means the force on O when you will be drawing due to C, it will be going away. So this blue line will indicate your FOC. I'm going to put a dot here just to tell you that the blue line here indicates your FOC. Okay. Now let us go for the next FOD direction. How I can draw that? So you can help now. O is 1, D -5. Two charges are opposite in signs, that is unlike charges. That means it will give in to electrostatic attraction. That means you will be drawing FOD in this direction. This is your FOD. FOD. Okay. So I'll just indicate here. So I have got all the directions now. Now you should know that to find the resultant between two vectors, if I have to find the resultant between two vectors, these are all vector addition problems. So we already know that to find the vector or resultant vector for the two vectors, we have a formula of magnitude, that is R is equal to root of P square plus Q square plus 2PQ cos theta. This was used and this was very popularly known in your 11th standard as parallelogram law of vector addition. So now if I want to add, I will add two vectors at a time. First I'll be adding FO and FOC, and then I'll be adding OB and OD because they are in same line. So it will be easy for me. And then I can add the resultants of these two. So for these OA and OC, let me write this as resultant vector 1. And for these two addition, I'm going to get one more vector, that is R2. Okay. Now when you see OA and OC, are they in same line? Yes, they are in same line. But are they in same direction? No, they are in opposite direction. That means the angle between them, the theta here is 180 degree. In these cases, when two vectors you are adding and they are opposite in direction and they are having 180 degree angle between them, then when you solve this, you get P minus Q resultant. That means this will come P square plus Q square minus 2PQ, because cos 180 is -1. You will get P minus Q. That means these vectors can be simply subtracted to get the answer rather than using all the fundas. These are special cases where you can normally subtract the vectors. Usually it is not possible because they are not scalars, but this is a special case where it is possible. So I can clearly write FOA vector plus FOC vector as FOA minus FOC. So, or I could have written like this to start with, to begin with, that this is nothing but R1 vector plus R2 vector. So for me, this R1 is FOA minus FOC. R2 is between what all? FOB and FOD. Now clearly FOB and FOD, when you see here, the green and the gray line, again, this is the same kind of case where the two vectors are in opposite direction, 180 degree to each other. So again, your R2 vector can be written simply as FOB minus FOD. Now you should ask a question that, sir, how you are able to decide whether it is FOA minus FOC or FOC minus FOA. Always remember, the vector which is greater in magnitude will come first. In this case, it is not going to be an issue. You will see it in a short while. Why? Because now when you will find the magnitude of FOA, you know to find the magnitude of electrostatic force, you have only one law, that is Coulomb's law we are going to use here. So Coulomb's law between two charges, when you have to say, you need to have a distance between them. That means we are now interested in the distance. So this distance is basically we are interested in now. I have made it in a red line. So now you know the total diagonal of a square. So if you are having a square of side A, then your diagonal is A root 2. How it happens? Because you use Pythagoras theorem, that is A square plus A square. When you solve it, you'll get A root 2. So you can see this side I am taking, this particular part, this is A, this is A. So diagonal will come A root 2. You can solve and see. Similarly, the diagonal, we are only considering the half of diagonal. So that means the distance we are interested, So D, the R which we are interested right now is A root 2 upon 2. In this particular is what is A? 10 centimeter given in the question. So it will become 10 root 2 upon 2. That is nothing but 5 root 2 centimeter. This will become 5 root 2 centimeter. Root 2 centimeters. Or in meters, how I will write? 5 root 2, because I have to use in SI unit, 5 root 2 into 10 raised to power minus 2 meter. Similarly, the charges are given in micro. Micro is 10 raised to power minus 6. So the charges will be written in into 10 raised to power. You have to remember this, that 1 micro is 10 raised to power minus 6. So you need to change this too. So when you will change this, you will see that FOA becomes K into. Now what is the OA? So I'm going to write here OA. So OA, O charge is what? 1 microcoulomb. So I am going to write here. So I am going to write 1 into 10 raised to power minus 6. Similarly, the second charge, how much is second charge here? How much is the second charge? The second charge, that is nothing but your A. A is 2 into 10 raised to power minus 6 divided by, what is your R square? R is nothing but, already we have found out, 5 root 2, everything will be same, all the distance 10 minus 2 whole square. Similarly, when you write OC, you will see that you will get same thing, K, you will get same thing, that is nothing but K into 1 into 10 raised to power minus 6 into 2 into 10 raised to power minus 6 divided by 5 root 2 into 10 raised to power minus 2 whole square. Okay, then FOB, please help me, I'm going in next step. So OB will be nothing but K into, again O is 1 into 10 raised to power minus 6, but what is the charge at B? Minus 5. So 5 into 10 raised to power minus 6. Now many students will have confusion that why you have not taken the negative sign. Always remember, negative sign is only used for direction. So when you're finding the magnitude, you don't consider negative. Very, very important. So now this distance again is same, 5 root 2 into 10 minus 6 minus, 10 minus 2. I'm extremely sorry. And this is the whole square. And likewise, minus, this will become K into 1 into 10 raised to power minus 6 into 2 into 10 raised to power, this is 5 into 10 raised to power minus 6 divided by 5 root 2 into 10 raised to power minus 2 whole square, because the charge at D is also minus 5 microcoulomb. That is the reason. So now you will see this and this cancels because they are same. Similarly, this and this cancels because they are same, and you get finally your FO vector, which we are interested is 0. So the net force on the charge O, that is 1 microcoulomb at the center of the square, is 0. Okay, have you understood this? Thank you. Let's meet for the next video. Thank you.